to talk about the naming a test or an interval. And so we're going to combine all the intervals and tests that we have done so far and see what's going on with that. So first of all, what we're going to do is we're going to kind of just talk in general what the interval and the tests do. Okay? So the first thing that we want to talk about is that when you have an interval, okay, so when you have an interval, then what you, of course, do is you have that range of plausible values, okay? Remember, that's your interval. And you're 95% confident that the true proportion or the true mean is between this and that. So what you are doing with an interval is you are estimating an amount, okay? So you're estimating an amount. All right. And then you're hoping to kind of get that plausible range for what that is. Okay? With a test, then you're going to be checking to see, you're going to be testing a claim. Testing a claim. So, in other words, you're going to get, you're going to have a yes, no answer, okay, to if something is as claimed. All right. Now, the next thing that we want to talk about is, of course, how do you tell the difference between if something is a mean versus a proportion? Okay, so that's the next thing that we want to deal with is the mean versus the proportion. All right. So first of all, we know that with our mean, we have quantity amounts. A quantity. So there is like a numerical value, a numerical amount of how much something is, or versus a proportion, which is happening with categorical data. And so this is categorical data, so we're getting like what proportion of people say yes versus no. Okay, what proportion of people say this or that? What proportion of people did this or did that? Okay, so really it's just people did something, or the subjects did something, or they didn't. Okay, so you can see that I've got a shortcut method where we have CIs for confidence intervals, and then you have one mean or one proportion. Two separate means or two proportions, and then PD is for paired data. Paired data, FYI, can only happen with means. Okay, so paired data can only be with means because you have one subject who had one measurement first and then another measurement second, or twins that had two separate measurements, not one subject doing yes or this or that, is doing something or not doing something. All right, and then for hypothesis test, we're going to notate that with HT, and then 1M for one mean and 1P for one proportion, two means, two proportions, and paired. All right, so this is just kind of Ms. McClellan's shortcut. This is not necessarily standard. So when you name a test or an interval, when you're doing a phantoms or a panic model, you cannot just write these little shortcut things. This is just our quick way of notating that as we just go through this process of identifying what type of test or interval the question is wondering about. Okay, the scenario is about. So here we go. Number one, let's go through this. The average cholesterol level for people in their 40s is 192. Okay, so in my mind what I see is, I saw the word average, so that kind of makes me think, maybe we're going to be doing mean problems. Okay. The second thing that clues into me is, they had a claim. Okay, all right. So you are interested in seeing if that average cholesterol is different for vegetarians in their 40s. Okay, this is just kind of telling me that if I was to do a test, it would be a not equal to. All right, 56 vegetarians in their 40s were tested for their cholesterol level. Okay? So what I see from here is that we have one sample's worth of information. All right, so here's my thought process. I say, okay, we have a claim. We are going to test this claim to see if it is now something else other than 192, and I have one sample. Therefore, my decision is that this is a hypothesis test for 1, and then these are cholesterol levels, so those would be numerical amounts, so that's a mean. So a hypothesis test for 1 mean. Okay? So read the next one to yourself and kind of talk through that one and see what you think there. Okay? Do that now. Okay. So I see we have 2 separate sets of subjects. We have 50 subjects that were asked something at Sierra at Tahoe, and then 50 subjects that were Kirkwood. I guess these are sliders like skiers or something. I don't know. Okay, so I have 2 different sets of subjects. So I can tell right now I have 2 samples. All right. So are they more likely to spend the night in the basin? So what would be the result I would get when I inquire this from the 50 people at Sierra at Tahoe? Okay, I would say, are you spending the night in the basin? And they would say, yes, I am, or no, I am not. So I would end up getting a proportion of the people at the Sierra at Tahoe location versus the proportion of people at the Kirkwood resort. Okay? So I would be comparing those 2 proportions and seeing if one thing is greater than the other. So I don't have a claim here necessarily, like where I'm trying to estimate how much more that is. If it said how much more is this than that, that would be an estimate, and that would be an interval. But it wants to know, actually test the claim to see if one number is more than the other. So I think that's hypothesis test for 2 proportions. Okay, take a look at the next one. Okay, so one thing I see is I have 500 crying infants in the swing and 300 crying infants that were talked to. So in a sense, those were the treatments, okay? All right. And so what I'm trying to see, the result is, do they stop crying? Okay? So what kind of answer are we going to get from these 500 infants in the swing versus the 300 infants that are talked to? And so I would think I would be getting the proportion of the 500 who stop crying that are in the baby swings and the proportion of the 300 that were talked to who stop crying. So in my mind, I'm thinking, I know I have 2 proportion amounts. Okay. And I'm comparing those amounts, okay? But I'm not just saying, hey, test to see if one is more likely than the other, like we did in problem 2. I am actually being asked this: how much more effective is one than the other? That is important. That means that I am estimating an amount. And since I am estimating how much more one is than the other, then that is what makes this an interval, not a test. It's not saying just is one more than the other? Okay, that's a test. How much more is one than the other? That's an interval. So on this problem, I have a confidence interval for two proportions. All right. Next, read the next one to yourself and see what you can come up with. Okay. So, what kind of question are you going to get in the end? Do men spend a higher percent of their time? Am I going to get a yes they do or no they don't? Or am I going to say a number? How much more time do they spend outside? Okay? It is not an interval. I'm not giving a numerical value of estimating how much more men spend than women. I'm just saying, do they spend more? Yes or no? The alternative is going to be that the men is more. Okay. So I can tell I'm going to be doing a hypothesis test with two different samples. Now, if I remember correctly, this one actually is kind of a tricky one in that it is very instinctual to see this percent of time. Okay? And so a lot of people go, oh, this is a proportion problem. Okay? But you know what? Let's really analyze this. Okay? If I took all the boys in the class and I said, okay, every single boy, tell me your estimate of how much percent of time do you spend outdoors? And I would go around the room and I would get all the boys' percent. Okay? So I would get the percent from every boy or every man, and I would then say, okay, girls, what percent of time do you spend outside? And then I'm going to get the percent from every girl, every woman. And you know what? Ultimately, what am I going to get of those numbers? I'm going to get, this is what's tricky about this one, is I'm going to be getting an average percent of time spent outdoors. So that is tricky. It's actually a hypothesis test for two means. I did this one year correctly, and then the next year I did it right. And so anyway, so what I would like for you to do right now is to try a few more of these. Let me let you try numbers 5, 6, and 7. So pause the video, try numbers 5, 6, and 7, and then I'll pop those answers up to you, and then we'll try some of the other ones and check those. All right? So stop the video now and practice numbers 5, 6, and 7. All right. So let's go ahead and see how you did on numbers 5, 6, and 7. Okay. So I see with number 5, we were wanting to see how much more often do women order dessert compared to men. So I'm estimating an amount. That tells me it's an interval. So I can tell it's a confidence interval. All right. I have two different samples, men and women. So I know that's 2. And here's another one I think is kind of tricky. So what would I get? So you have to think about when you ask the question and you collect the data. I don't say, do you order dessert? Do you order dessert? Yes or no? If that was the way I asked the question, then I would have a proportion of men that order a dessert and a proportion of women that order a dessert. Think, because I'm asking how much more often do women do something than men, I would be saying, hey, woman, how much of the time do you order dessert? Okay, how often do you order dessert? And so they would tell me an average number of times that they would be ordering dessert. So again, we have to think, how is this data collected and what do those numbers look like? So my conclusion is confidence interval for 2 means for number 5. Number 6, I'm comparing getting death certificates and I'm putting into the piles. So I'm saying, okay, out of these 20,000, okay, here's the ones that were heart disease and here's the ones that were cancer. And so I have two different proportions, and I'm going to be comparing to see if it's more likely. So I have hypothesis test for two proportions, the proportion who died of heart disease, the proportion who died of cancer. Okay, and then there's other things, but I'm just checking those two proportions. All right, number 7, how many fewer calories do these do something? That's an estimate of an amount. So that's a confidence interval. And I have the 90 vegetarians and the 90 meat eaters, so I have two separate independent samples, and I'm taking their caloric intake. That's a number, so that's means. So it's a confidence interval for two means. All right, so you can, let me let you do the others, and then so pause this, and then you can, I'll work them, and then I'll put the answers up, and I'll go ahead and explain it, but you don't have to watch the rest of the video if you get those correct, okay? So let's let you work the other 8 through 13 and see how you do. All right, so let's check and see how you did. So here are the answers I have boxed in. 8 is HT2P. 9 is confidence interval for paired data. That's a paired one. 10 is confidence interval for one proportion. 11, confidence interval for one mean. 12, hypothesis test for two means. And 13, confidence interval for one proportion. So if you do not need me to go over that, then you can go ahead and stop this video and do the assignment related to this. And then this will be the similar format to your quiz that you'll have over this concept. So if you want me to go over this, here I go. Number 8. We are just wondering, is the virus protection software changing the proportion of times you get the virus, not estimating how much more likely you are? So it's a hypothesis test. We have 400 two separate samples, 400 who have the protection and 700 do not. 9, how much does the proper lighting improve museums? So we are actually estimating an amount. The visitors were rating it on a score of 1 to 10. That's a quantity, so I know that's a mean. But here's the thing. These visitors were rating it before the new lighting was installed and after the new lighting was installed. So I would be comparing their rating before and after, and I don't care how they rated it before or how they rated it after. I want to know how much change occurred. So then I will average that change. In this case, they want you to get a confidence interval for that paired data. Estimate the average change. Okay. Here it says in number 10, determine a likely range of values. Right there, that's what a confidence interval is for the true proportion of Americans in favor of this proposition. Are you in favor of it? Yes or no? That's a proportion of Americans. Confidence interval for one proportion. Number 11, determine a confidence interval. So that's a confidence interval for the average online score of this one set of people. Okay? So confidence interval for one mean. Number 12, do people living in houses make more money? Okay, so it's not asking you how much more do they make. How much more do they make would be a confidence interval. It wants to know, do they make it? Yes or no? We're not estimating. That's a hypothesis test for two separate means. Those who live in houses versus those who live in condos. And the last one, what proportion of car accidents cause serious injuries? So you're going to take one proportion. You're going to estimate one proportion. I'm estimating what that number is. That's a confidence interval. Okay? All right, so there were 13 problems for you to practice on. I hope that over the course of those, you've got a better hang of it, but it just takes practice, practice, practice. Okay? So go on to the assignment, practice it yourself, and I'll have a video going over what the answers to the assignment are, so you can check yourself on those.